the questions ask for what? I think we need to do our solution based on the question being asked. Okay. So this question said determine QS and M. Here, QS and M, we use its short form for axial force, shear force, and bending moment. Okay. So when you want to determine this, you have to know where. So at section A and B. So where is A and B? As shown here, A is 4 meters from D, B is 4 meters from E. So these are the two sections where internal forces, axial force Q, shear force S, and bending moments M are required. So now you have imagined I want to determine A and B. So I have to cut there at A and B and draw the free body diagram, whether I use the left-hand side of the cut section or the right-hand side of the cut sections. So if we cut, this is the first part, this is just to refresh you, this is a beam with a hinge. So this is a statically determinate beam. So this process, if you are asked to check statical determinacy of the beam or proof that this beam is statically determinate, so you have to carry out this process. So next, we want to know the QS and M, axial force, shear force, and bending moment at section B. So we cut at section B. Then, class, remember we have the choice to use the left-hand side of the cut section or the right-hand side of the cut sections. So which part should we use? You decide. We decide. So normally we choose the side where the number of forces that appear in the free body diagram is as small as possible, less number of forces, so that the calculation process becomes simpler. Any mistakes in the calculation process will be, the possibility will be smaller, because the forces that appear in that free body diagram, the forces that you need to consider in your equilibrium equation is less. So this is a free body diagram, class, that you need to consider. So here is the positive directions for Q, S, and M if you use the right-hand side of the cut sections here. So this one important, must show the internal forces and show the positive directions. So here we have a reactions. This is a roller support. So there is a vertical reaction EY, which I circle here. So we want to calculate this, and this. This load is given, but we don't know this. So we have to determine the reaction force first. So that is normally the first steps. Class, that is normally the first step when we want to calculate shear force and bending moment at a particular sections, or later on when you want to draw shear force diagram and bending moment diagram. This is normally the first step to calculate reaction force. And the first step must be make sure that you get it correctly. If the reaction is wrong, then the rest of the calculations, axial force, shear force, and bending moment will also be affected, also will be wrong. Okay, so the first step, get the support reactions must be done correctly. So EY has to be determined first. So this is also a kind of revisions for us. So this is a beam with hinge. So we cut this beam at the hinge location and indicate that there is a two internal forces here, because this is a hinge, which is a CX and CY. And we are not interested in CX and CY, class. Okay, so we focus, our attention is EY. We want to know EY. So we look at this free body diagram after we cut at the hinge, the right-hand side of it, and we take moment at the hinge here only for this part. That's why there's a superscript CE here, which is this free body. And we can get EY is equal to 60 kilonewton. So This is a revision also how to make use of the condition that there is a hinge in these beam problems, and then we make use of the equilibrium equation considering only this part. That's why there's a superscript CE here. Remember class, we have covered this. So we have obtained the reaction force EY. So next is to just go back to this free body diagram just now. Then the next of these steps is after you already obtain the reaction force, so all the forces are only force unknown forces are QS and M now, reaction force already determined. So the rest of the job that you need to do is apply equilibrium equation. There are 3 of them, so one by one you get axial force again 0. Shear force, take this force equilibrium equation, so shear 0. This case it happened to be 0 for this particular beam at this particular sections. Okay. Then bending moment, again class, please take bending moment at the bending moment. Take bending moment at the cut section, at the cut section. Okay, you can take bending moment, of course, at E, but then you need to consider S. So if your S calculated wrongly, then it might affect your bending moment. So it is advisable when you want to calculate bending moment using moment equilibrium equations. Okay, take moment at the cut section. Take moment at the cut section. So that is to avoid having to consider S, because S does not cause moment if you take moment at the cut sections. So sometimes if you get your S wrong, then your bending moment also will be wrong. Okay, so try to take moment at the cut sections when you want to evaluate bending moment at that cut sections. So when you take moment at the cut section, don't forget that the bending moment M here must be included. It will appear in that moment equilibrium equations. So this is a simple example again to how to get a bending moment and shear force at the particular sections, So I leave it to you, try to get the Q, S, and M at A now. At A, because this question asks for Q, axial force, shear force S, and bending moment at section B and A. So where is A? So look at where is A and do the corresponding cut. And then from there, make use of either the left-hand side, the left-hand portion of the cut, or right-hand portion of the cut. Then draw the free body diagram, indicate the portions of Q, S, and M following the conventions, the sign conventions. Then after that, make sure that all the reaction forces are determined. Then use the 3 equilibrium equations to get the Q, S, and M. Okay. So try to get the Q, S, and M, and the answer should be Q0 as 120, M negative 360. And negative 360 means the positive direction that you assume actually at that particular section. The bending moment is in the other directions, opposite to that. Okay. So now, let's take a short break, and after that, I will bring you to shear and bending moment diagrams now, which is the main aim for this particular our lectures today, is looking at the ways to get shear and bending moment diagrams. Okay, get back to the basic principle again. What is the steps involved? And the most important thing is how to get the shear and bending moment diagrams from the calculation that you have gone through, the steps involved, and finally how to get the shear and bending moment diagrams. And what are the important things that you need to take note when you draw shear and bending moment diagrams? So that will help you so that the shear and bending moment diagrams that you draw are reasonable and correct. So you have a way to check. There are certain characteristics of the shear force and bending moment diagrams in relations to the loading conditions that we can make use of to make sure that the shear force and bending moment diagram that we draw are correct. So remember class, this shear force and bending moment diagram are important informations that we need when we do design. So it's very important to get this, to master the drawing of shear force and bending moment diagram. So some books call shear diagram, some books call shear force diagram. So either way, it is okay, can be used. So here I show shear diagrams. It means also shear force diagram. And shear and bending moment diagrams, it shows, what does it show? It shows the variations. It shows the variations of shear and bending moment along the length of the member. Okay, so that is the next thing that I will be looking at when we, after the short break, we take about 5 minutes short break. Okay. So we take a break for 5 minutes. Then after that, at around 10 o'clock, we resume again. Okay, class. So we take a short break. Meanwhile, if you want to talk to me or just say hello, and then you're welcome, but we will take a short break. Okay, so there are 88 of you now in the, that is very good. We take a short break, class, 5 minutes. you.